Hello friends, in this video we will study about the command words of Programmable Interrupt Controller 8259, which is also known as PIC. So let's start with our topic. The 8259 programmable interrupt controller, it can work in various modes of operation. Okay, so there are various operational modes, and for these operational modes we have different control words. These control words, they are also known as the command words. So in this video we are going to study about the command words of 8259, which decides the mode of operation of this PIC. Okay, now the command words of 8259, they are of two types. First is the initialization command words and second is the operation command words. So this 8259, it is going to have two types of command words: initialization, that is ICW command words, and operation command words, that is OCW. Now, as the name says, that initialization command words, they are used to initialize the 8259 IC. So these command words are given before we are using the 8259 IC. So just to initialize the 8259, these command words are given. And the operation command words, they decides the different modes of operation of 8259. So we will have two types of command words. First, we will start with the initialization command words. So before the 8259 IC is used, the initialization command words are given. So before this 8259 IC start functioning, it has to be initialized by writing the initialization command words. Now these initialization command words, there can be two or more than two initialization command words. So we have here four initialization command words: ICW1, ICW2, ICW3 and ICW4. So there are four initialization command words. First, we will start with the initialization command word first. Now this command word is written if A0 is equals to 0 and D4 is equal to 1. Okay, then the control word is the data which is provided by the CPU to the 8259 through the data bus. Okay, so that control word that is given by the CPU, if A0 is equals to 0 and the D4 bit is equal to 1, then the control word is the initialization command word first. Okay, now if A0 is equal to 1, then the control word is the initialization command word second. Okay, now coming to the initialization command word third, this command word is used whenever the 8259 IC, it is working in the master slave configuration. So it is used whenever we have master slave configuration. It means that when we are using several 8259 ICs cascaded as to each other, so this command word will work only when the ICs are in master slave configuration. And this initialization command word fourth, it will be used when in the initialization command word first, if the ICW4 bit it is equal to 1. Only when this bit in this first initialization command word it is 1, then only this command word will come into execution. And this command word, it decides the various modes of operation of 8259. Okay, so this is just a small introduction about the four initialization command words. We will see the control word format for all these four these command words. Okay. Now let us first come to the flow chart, which describes the steps or the sequence in which these initialization command words are given. So so just see first the flow chart for it. First, the initialization command word first is given. Then the initialization command word second will be executed. Then it is checked that whether the 8259 IC it is in the cascade mode or in the single mode. Okay. So this is the initialization sequence of 8259. You can see that first we have the initialization command word first, then second. Then in the initialization command word first, we have a bit which decides that whether the 8259 IC it is in the cascade mode or it is in the single mode. Okay, cascaded mode means there are many number of 8259 ICs which are connected, which are cascaded with each other, and single mode means that only one 8259 IC is working. So here after this ICW2, it is checked that whether it is in cascade mode or not. So it will be in cascade mode when this single line, which is given in the initialization command word first, if that single line is 0, then it is in cascade mode. If this single input it is 1, it means it is not in the cascade mode, it is working as a single 8259 IC. So when this is in cascade mode, then the command word third will be initialized, will be given. Then it is checked that if ICW4 or the IC4 bit in the first initialization command word, is it equal to 1? If it is equal to 1, then only the fourth command word will be executed. Otherwise, the next step that it is ready to accept the interrupt request, the 8259, it is ready to accept the interrupt request from all the input output devices. So that will be done. So this is describing the initialization process of 8259. Okay, ICW1 will be loaded, then ICW2 will be loaded, then it is checked that whether it is in cascade mode or in the single mode. Okay, then IC4 will be checked. If it is 1, then fourth command word will be initialized. Otherwise, the 8259, it is ready to accept the interrupt request. So this was the initialization sequence. So you can see that these initialization command words, they are basically initializing the IC. They are making it ready for its operation. Okay. Now let's come to the points which after the initialization, what will be the status of the 8259 IC. Okay. So in the flowchart, you have seen that first initialization command word ICW1 is given. So the first step of the initialization process was to load the first command word ICW1. Now, once this ICW1 is loaded, then the following procedure is carried out in the 8259 internally. The first step in this is that edge sense circuit is reset. Now the 8259 IC, it can accept the interrupt which can be either level triggered or edge triggered. So once this ICW1 is loaded, the 8259 interrupts, they are by default set as the edge sensitive interrupts. Okay, so the first step is taken as to make all the interrupts of the 8259 as edge sensitive by default. Okay, then next is interrupt mask register IMR, it is cleared. This interrupt mask register, it stores the information about the interrupts which are masked. Okay, so initially at the time of initialization, all the interrupts, they are in unmasked condition. Okay, no interrupt is masked by the 8259. So this IMR register, it is cleared when the 8259 IC, it is initialized. Now there can be 8 interrupts. They can be given to the 8259. Now out of these 8 interrupts, that is from IR0 to IR7, we have the IR7 interrupt request which is assigned the lowest priority. Okay, so whenever this interrupt request is given, the if 2 or more interrupts are given and one of the interrupt is IR7, so IR7 will have the lowest priority. So by default, at the time of initialization, IR7 has been assigned the lowest priority among the interrupt signals. Now, this in when the 8259, when we are having like one or more 8259 ICs are connected, so one IC will act as the master 8259 and others will act as the slave 8259 ICs. So the slave mode, in the slave mode address, it is set to 7. Okay, so the master IC, that will be given a fixed address at the time of initialization. It is set to 7. So this is fixed by default. Now, one of the mode of 8259 is the special mask mode. So when this 8259 is initialized, this special mask mode is cleared and the status read is set to the interrupt request register. Okay, so the status which is read by the microprocessor, that is by default set at the interrupt request registers. So when it is initialized, the status which is read by microprocessor, that will be the status of the interrupt request. So whenever any request is generated, that will be first accessed by the 8259. So if this IC4 bit in the first initialization command word, that is ICW1, if it is 0, then all the functions of the fourth initialization command word, they are set to 0. And also the master slave bit in the ICW4, it is used in the buffered mode only. So there were 4 initialization command words. So let us study the format of these command words for all the 4 initialization. Okay? Initialization command words. First we will start with the initialization command word first, which is known as ICW1. Now these command words, they will be of 8 bit, having the bits D0 to D7. Okay, and these bits, they will have some of the functions. Okay, now this initialization command word first, it has the control bits for deciding that whether the 8259 it is in single mode or the cascade mode, and the call address interval, level or edge triggered. So it decides, it has the control bits for all these functions. So we can write here that this command word ICW1, it contains control bits So this ICW1, it has the control bits for edge and level triggered mode, for single cascade mode, for the call address interval, and also that whether the fourth initialization command word ICW4 is required or not. So let us see the format of this ICW1. So the 8 bits of the command word starting from D0 to D7, these are described here. And for the initialization command word ICW1, the A0 it has to be 0 and D4 bit it has to be 1. Then only this ICW1 will be selected. So the set bits are A0 has to be 0 and D4 bit it has to be 1 for ICW1 to be selected. Now let's start from D0. D0 bit, it is assigned IC4. So when this bit is 1, it means that the initialization command word fourth it is needed. Otherwise, if it is 0, it means that ICW4 it is not needed. So we can say that D0, if it is 1, then ICW4 needed. If it is 0, then ICW4 not required. So this bit is going to decide that whether the fourth initialization command word is required or not. Then we have D1, which is SNGL, means single or cascaded. So when this bit is 1, it means that the 8259 IC, it is in single mode, and when it is 0, it means it's in cascade mode. Okay, so this bit, it is going to decide that whether the 8259 IC, it is in single mode or it is in cascade mode. Then we have the D2 bit, which is ADI, and this bit controls the call address interval. So D2 bit, it is for the call address interval. So if it is 1, then the interval between the call addresses, it is of 4 bytes. And if it is 0, then the interval, it is of 8 bytes. This call address interval means because this 8259 IC, it can accept 8 interrupt requests, and with every interrupt request there will be a service routine which is to be executed by the CPU. Now this service routine, it consists of the instructions call and return, and these service routines, they are written at some memory locations of the microprocessor. Now because 8 interrupts, they will have 8 service routines, and these service routines, they are written in the memory. So the interval of addresses between the call instructions of every service routine, it is decided by this D2 bit. So when this bit is 1, it means that the interval between the address locations, between the memory location, it is of 4 bytes, because if service routines, they are written at one place only, then how the microprocessor, it is going to decide that this service routine is for the first interrupt and this service routine, it is for the second interrupt. So the difference between the memory locations, between the addresses, it is decided by this bit. So if it is 1, then the interval between the call addresses, it is of 4 bytes, and if it is 0, then the interval between the addresses, it is of 8 bytes. Okay. Now next we have the D3 bit. D3 bit is LITM. This bit decides that the interrupt, it is either level triggered interrupt or edge triggered interrupt. So this is the control bit for the edge and level triggered mode. So D3 bit, if it is 1, then the interrupt, it is level triggered, and if it is 0, then the interrupt, it is edge triggered. Okay, so triggering whether level or edge, it is decided by the D3 bit. Then we have D4, D5. D4, it is already said that it is always 1 for the ICW1. D5, D6 and D7, these are the addresses, because the address of the service routine, it is provided by the microprocessor, it is provided by the 8259 to the microprocessor. Okay, that at this memory location the service routine is written. So the address is, it will be either of 8 bits or it will be of 16 bits. Okay, so that address, the A5, A6 and A7 bit, it is provided by the 3 bits of this initialization command words. So we can say that these are the A7, A6 and A5 bits of the call of the interrupt vector address. Okay, so D5, D6 and D7, these are the A5, A6 and A7 bits of interrupt vector address. and this is applicable only for the microprocessor 8080 and 8085. Okay, so for these two microprocessors only, these D5, D6, D7 will represent the A5, A6 and A7 bits of the interrupt vector address. So this was our first initialization command word, which has the control bits for the edge and level triggered mode, for single cascade mode, for call address interval, and whether ICW, the fourth initialization command word, is required or not. So the 8 bits of this first initialization command words, we have discussed that what are the function of these 8 bits. Now let us come to the second initialization command word, ICW2. So this second initialization command word ICW2, it stores the details regarding the interrupt vector address. Means the address where the service routine is written. Okay, ISR, that is interrupt service routine, is written. So that address will be provided by the second initialization command word. Now let us see the 8 bits of this command word, because it will be an 8-bit command word. So what the 8 bits their function are, let us see. Now for the second initialization command word, the A0 address line, it has to be 1. Okay, for first initialization command word, this A0 line was 0. For second initialization command word, this is 1. Now D7, so these are the 8 bits of the second initialization command word. D7, it is T7, T6, T5, T4, T3, and then D2, D1, D0 are A10, A9 and A8. Let us see what these bits describe. Now this T7 to T3, these are the A3 to A0 bits of the interrupt vector address. As the second initialization command words, it provides the interrupt vector address. So we have seen that the interrupt vector address, it will be of 8-bit or of 16-bit. So in the case of 8080 microprocessor and 8085, the interrupt vector address, it will be of 16-bit or either 8-bit. Okay, so the A0 to A3 bits of that address, they are the T7 to T3 bits of the ICW2. Okay, then we have D2, D1, D0, they are A8, A9 and A10 bits. These 3 bits, they are used to decide the 8 interrupt requests, because this 8259 IC, it has the interrupt request from IR0 to IR7. Okay, so these 8 interrupt requests will be selected by using these 3 bits, A10, A9 and A8, like 000, 001, 010 till it is 111. So these 8 combinations, they will be corresponding requests are associated with it. Like for IR0, we have 000. So if these bits are 000, then this first interrupt request will be selected. If it is 001, then second interrupt request IR1 will be selected. If it is 111, then the 8th interrupt request IR7 will be selected. So these 3 bits, they are selected according to the interrupt request level. So we can say that now when the 8259 IC, it is communicating with the 8085 microprocessor, then A15 to A8 of the interrupt vector address are the respective bits of the ICW2. Okay, so if this 8085 microprocessor it is communicating, then A15 to A8 starting, this is A15, A14, then 13, 12, 11, 10, 9, 8. So these 8 bits are the 8 bits of the interrupt vector addresses. Okay. Now in 8086 and 8088, A15 to A11, so in 8086 and 8088 microprocessor, A15 to A11 of the interrupt vector address, they are inserted in place of T7 to T3. So there are two ways in which 8259 can communicate. It can either communicate with 8085 and it can also communicate with 8086 and 8088. So when it is communicated with 85, then A15 to A8 will be the 8 bits of this ICW2. If it is communicating with 8086 and 8088, then A15 to A11 of the interrupt vector address are inserted in place of T7 to T3. So A15 to A11 will be here, and these 3 bits, they will decide that which interrupt request level is to be selected from IR0 to IR7. So this ICW2 initialization command word second, it gives us the details regarding the interrupt vector addresses, because all the bits of this command word, they are representing the address bits of the interrupt vector address. Now let us come to the third initialization command word. So this was the third initialization command word. The first two initialization command words, ICW1 and ICW2, they were the compulsory command words, whereas ICW3 and ICW4, they are the optional command words. Now this command word ICW3, it decides whether the 8259 IC, it is working in the master mode or the slave mode. So let us see the 8 bits, what the 8 bits of this command word they describe. Now, as this command word, it decided whether 8259 it is working in master mode or in slave mode. So it has two control word. One is for the master mode and one is for the slave mode. So that is known as the master ICW3, and this is known as the slave ICW3. Now let us see the bits. The A0 bit, it is 1 for this ICW3 mode. Okay. Then D7 bit, Basically, the function of this initialization command word third is to load an 8-bit slave register. Okay, so we can write it here that it loads an 8-bit slave register. Now in the master mode, this master mode will be selected if the SP and enable line or this pin of the 8259 IC, if this pin it is 1, then then this 8259 it is working in the master mode, and then this master ICW3 will be executed. So when this SP and enable line it is 1, or in buffered mode, okay, in buffer mode also, when 8259 it is working in the buffer mode, then also this master ICW3 will be selected or this will be executed. Okay, now when this master mode will be executed, this will depend upon the M or S line in the ICW4. When this line is 1, then the 8259 it is working in the master mode, so this master ICW3 will be selected. Now these 8 bits of this ICW3, master ICW3, they are representing the 8 bits of the slave register. Okay, so when these bits, if any of the bit is set, it means that the IRN has a slave input. Okay, so these 8 bits, they are used to set the bits of the slave register. Okay, so if Sn is equals to 1, suppose S4 is set. Okay, so this is set, it means IR4 it has a slave input, means the interrupt request line of the fourth number, that is IR4, it is having a slave input. And if this bit it is 0, it means that the IRN does not have a slave input. Okay, so these 8 bits of this master ICW3, they are used to set or reset the bits of the slave register. Okay, now let's come to this slave ICW3. Now when this slave ICW3 will be selected, when this SP or the enable line it is 0, and the buffer mode, if this 8259 IC it is not working in the buffered mode, means that the master and slave bit in the ICW4 it is 0. So it will be selected when SP and enable line it is 0, or this MS this line will be 0. Then only this slave ICW3 will work. Now let us see what these 8 bits they describe. The D7, D6, D5, D4 and D3, they are at the constant logic 0. Their value is set. And the 3 bits D2, D1 and D0, they are the identification bits. Identification bits means these bits are used to identify the slave IC. Okay, so their combinations, 3 bits we can have 000, 001 till 111. So these 8 combinations will identify the 8 slave inputs. Okay, so here I have D2, D1 and D0. Their value can change from 000 to 111 for IR0 to IR7. Okay, for the 8 interrupt request, it can have the 8 combinations, or we can say that we have the 8 slave inputs. So which slave register is selected or which slave input is selected, that is decided by these 3 bits. So we can say that these are the bits for slave 1 to slave 8. So this initialization command word third, it is deciding that whether the 8259 IC it is working in the master mode or the slave mode. Now this mode selection, master mode, slave mode, it is decided by the SP and the enable line. If it is 1, then the 8259 it is working in master mode. If it is 0, then it is working in the slave mode. Also the M/S bit of the ICW4, that is the fourth initialization command word, if this bit it is set, that means 8259 it is in master mode, and if it is 0, then it means it is in the slave mode. So according to the mode, these command words will be executed. In master mode, this first command word will be selected, and in second, in the slave mode, the second command word will be executed. So this was the initialization command word third. Now let's come to the ICW4, that is fourth initialization command word. Now this fourth initialization command word, it decides the modes of operation of the 8259. Okay, so let us see the 8 bits, what the function of the 8 bits of this command word have. So this is the command word for the fourth initialization command word. This A0 bit, it is set to 1. Then we have 0, 0, 0. So the 8 bits of this initialization command word, they are described here. D7, D6, D5, they are always at logic 0. Their value is set. Okay. Then we have D4 bit, which is for S, F, N, M. Means D4, S, F, N, M. The full form of this is special fully nested mode. This is one of the modes of operation of 8259 IC. So it is a special fully nested mode. So when this D4 bit it is set, then this mode is selected, SFNM mode is selected. If it is 0 means reset, the mode is not selected. So it is used to select the special fully nested mode of operation of 8259. Then we have D3. This D3, it is for the buffer mode. So if this D3 bit it is 1, then buffered mode is selected. And if it is 0, then it is not selected. Then we have M/S, this D2 bit. This is for the master and the slave mode selection. M is for master and S is for slave mode. So when this bit it is 1, then 8259 is a master, and if it is 0, then 8259 is a slave. Okay, so this master and slave mode, it depends upon this D3 bit buffered mode. Okay, so when this D3 bit, this buffered mode is selected, then only this D2 bit is considered. If this bit is 0, that means if buffered mode is not selected, then this D2 bit it is neglected. Okay, so the use of D2 bit, that is the master and slave mode selection, it is necessary only when the buffered mode is selected. Then we have D1, which is AEOI. It means automatic end of interrupt mode. Okay, this is also one of the mode of operation of the 8259. AEOI, which is automatic end of interrupt mode. Okay, so again, when this D1 bit it is 1, then this mode is selected. If it is 0, then mode is not selected. Then we have the D0 bit, which is microprocessor. Okay, now when this bit it is 0, it means that 8085 microprocessor is selected, and if it is 1, then 8086 or 8088 microprocessor is selected. Because this 8259 IC, it can communicate with both the types of microprocessor, 8085 also and 8086 or higher versions also. So when this bit is 0, it means that the 8259 it is communicating with 8085, and if it is 1, it means it is communicating with the higher versions 8086 and 8088. Okay, so these are the four initialization command words, ICW1 to ICW4. These command words, they are of 8 bits, and all the 8 bits of the initialization command words, they have some particular functions. And these initialization command words are used to initialize the 8259. So before using 8259, these command words have to be given to the 8259 IC so that it can be initialized, and after the initialization it can operate in any of the modes of operations. So when we started this video, we studied that the command words of 8259, they are of two types. One was the initialization command word, which are required to initialize the 8259, and the other type are the operation command words. Now initialization command words we have already studied. Now let us come to the operation command words. These operation command words, they are required to use the 8259 IC in the various modes of operations. Okay, now there are various modes of this operational modes of 8259, like special fully nested mode, then we have buffer mode, end of interrupt mode, automatic end of interrupt mode, specific mode, non-specific mode. So there are various types of modes of operation. Now these modes of operation, they will be selected using the operation command words. So let us study about these. Now the modes of operation of the 8259, they can be selected by writing the control words in the 3 internal registers, which are known as the operation command registers, and these control words are known as the operation command words. Now there are 3 internal registers, so we will have 3 operation command words: OCW1, OCW2 and OCW3. So let us study these command words one by one, that what the 8 bits of these command words they describe. Okay, so first we will start with the operation command word first. So this is the first operation command word OCW1. These are the 8 bits. You can see that the A0 address line, it is 0. So when it is 0, then OCW1 will be selected. Okay. Then the 8 bits of these operation command word first, it is used to mask the interrupt request. Okay, because this 8259, it has the facility to mask the interrupts, also to set the priority of the registers also. So the interrupts can be masked using these 8 bits of OCW1. If these bits M0 to M7, these are set, then the interrupt request is masked, and if it is 0, then mask is reset. Means when the value it is 1, it is set. If it is 0, it is called reset. So if it is 1, then the interrupt request is masked. And if it is 0, then interrupt request is unmasked. So these 8 bits of the operation command words OCW1, these bits are used to mask or unmask the interrupt request which are given to the 8259. Now these 8 interrupt requests are from IR0 to IR7. So for these bits we have, like for IR0 we will have M0, and for IR7 we will have M7. Okay, so suppose if M4 is set, means if this is masked, if its value is 1, then IR4 interrupt request will be masked, and all other, if they are 0, they are unmasked. Okay, so this masking and unmasking of the interrupt request, they can be done using the operation command word OCW1. Okay, you have to just make the corresponding bit of that interrupt request set, so that will be masked, and if it is reset, then it will be unmasked. Now let us come to the operation command word second, OCW2. So let us see that what the 8 bits of this operation command words they describe. Now again, this A0 bit, it is 0. Then we have D7, D6 and D5. They are R, SL and EOI. Then D4 and D3, they are at the constant logic 0, 0. Then we have D2, D1 and D0, which are L2, L1 and L0. Okay. So these 3 bits, they are used for the various operations like rotation, specific rotation and end of interrupt. Okay, and these L2, L1 and L0, they are used to select the interrupt request. So let us see that what these are. SL and EOI combinations, they are specifying the various modes of the 8259. Okay, so when these bits, so these 3 bits, they can have different combinations. So let's see that what these combinations, they describe the functions. First we will have 0, 0, 1. Okay, so these are SL and end of interrupt. They are used to have the various combination of the rotate and end of interrupt modes. Okay, so when these bits are 001, it means it's a non-specific end of interrupt command. The end of interrupt commands, it can be of two types, specific and non-specific. So if it is 1001, it means it's a non-specific end of interrupt command, because EOI bit it is set, but SL bit it is 0. Now if SL bit is also 1 and EOI is also 1, then it becomes a specific end of interrupt command. So these two are to decide the end of interrupt commands, whether it is a specific or it is non-specific. Then we have this is our end of interrupt, it is set, and R it is also set, but the specific bit it is not set. It means that you have to rotate mode on non-specific end of interrupt command. If it is 0, it means the end of interrupt command it is non-specific. Okay, so here we have to rotate on non-specific end of interrupt command. Now if this bit becomes 0, then the end of interrupt command it is automatic. The EOI command, it is also of two types. One, it is self-generated, which we called as EOI command, and another is automatic EOI command. Okay, so if this bit is 0, then the automatic EOI mode is selected, and 1 is there, so you have to rotate. So rotate in automatic EOI mode set. Then this is 0. So rotate in automatic EOI mode clear. So that is the difference when this R bit is changed. Also this is 00. So we have the automatic end of interrupt command and also non-specific. Then if all the three bits are set, then rotate on specific end of interrupt command. So if it is 1, then end of interrupt is selected. If this is 1, then specific is selected, and if this is 1, it means rotate is selected. So the mode is rotate on specific end of interrupt command. Then we have this is 0, these two are 1, means rotate and specific. So this is the set priority command. So we can say that these two are for the specific rotation and these three are for the automatic rotation. You can see that here we have the automatic rotation command. So this is automatic rotation and this is specific rotation. Now when these two bits they are 0 and when this is specific bit it is 1, then no operation is performed, and these three bits they are used. Okay, so whenever these two bits are set, then L2, L1 and L0 are selected. So we can say that these three bits D7, D6, D5, which are L, R, SL and EOI, they these three bits control the end of interrupt, rotate and specific mode. And their combinations also. Now this D4 and D3 they are at the constant logic 0 0. So let's come to D2, D1 and D0, which are L2, L1 and L0. So these three bits they select the interrupt request which is to be used. So these three bits they can have different combinations from 0 0 0 to 1 1 1. So if it is 0 0 0, then first interrupt request IR0 is selected. If it is 1 1 1, then IR7 is selected. Okay. Now these three bits they will be active only if this SL bit it is 1. So if this bit is active, then only L2, L1 and L0 will work. So if we see the command word here, the SL bit, it is 1 in this case and also in these two cases. So when these two cases occur, then this L2, L1 and L0 bits, these are used to select the interrupt request, whether from IR0 to IR7, on which the mode has to be operated. So this was the operation command word second. Now let us come to the operation command word third. So this operation command words, the 8 bits, they are described here. A0 bit, it is always at 0 for the OCW3 to be selected. Then D7 bit, it is always at logic 0. Then we have D6 bit, which is ESMM. So this is the enable special mask mode. Okay, D6 bit, which is ESMM, means enable special mask mode. So when this D6 bit, it is 1, then this mode is selected, and if it is 0, then mode is not selected. So D6 bit, it is used to use or select or not the enable special mask mode. So when this bit is 1, then that mode is selected. If it is 0, then the mode is not selected. Now let us come to the D5 bit, which is SMM, means special mask mode. Now this bit, it is used to enable or disable the special mask mode. Okay, so when this bit, it is 1, it means that 8259 will operate in special mask mode, and if it is 0, then 8259 will not operate in special mask mode. So these two bits, they are used to enable or disable or to select the modes. Okay, so when this D6 bit, it is set, means if it is 1, then this special mask mode will operate. Okay, that means 8259, it is going to mask the bits only when this mode is selected and when this bit is 1. So when this is 1, then it will be masked. If it is 0, means reset, then it will be not masked. Okay, and to enable or disable this special mask mode, this D6 bit is used. Then D4, D3, they are at the constant logic 0 and 1. Then we have D2, D1 and D0. So let us see its functions here. This D2 bit, it is denoted as P. So one of the mode of operation of 8259, it is the hold mode. So this P bit, if it is 1, then 8259 will send the poll command, and if it is 0, then no poll command. Okay, then we have D1 and D0. D1 is RR and D0 is RIS. So when this D1 bit, it is set, Okay. So when this D1 bit, it is 1, and this RIS bit, if it is 1, then means IR register on the next read pulse, the 8259 it is going to read, and then if D0 it is equal to 1, then the IS register, in service register, will be read on the next read pulse. So these registers will be read by the microprocessor on the 8259. So if we see the operation command word third, then you can see that D6 and D5 they are selecting the special mask mode, and D2 it is for the poll mode, and D1 and D0 they are used to read the in service register and the interrupt request registers. Okay, so all these three command words, the three operation command words, they are initializing, or they are using the 8259 IC in the various modes of operations. We know that 8259 it can work in various modes like specific mode, rotation mode, then end of interrupt mode. There are various modes. There are 11 modes of 8259. So all these 11 modes they can be selected using these three operation command words. Okay. So in this video, we studied the command words of the programmable interrupt controller 8259, the two types initialization command words and the operation command words. There were 4 initialization command words, ICW1 to ICW4, and 3 operation command words, OCW1 to OCW3. So I hope that this topic is clear to you. Thank you.